Hello everyone and welcome back to Exam Prep Solutions, and today we have another sample problem here. We're going to be going over concrete design, specifically solving for the flexural strength. And you can see there's a lot of terms here that we need to know in regards to these problems. Now don't be overwhelmed. All the definitions are on the right here. They're taken from the FE reference manual that you should have out anytime you're doing a practice problem. And so we're going to use that as our reference when we're going through this problem. So it's find the design flexural strength in inch-pounds of the tension-controlled section of the beam seen below. F of y is 2000 psi and F prime of c is 1500 psi. And so we're going to need to find that flexural strength. And so we have the equation here for the nominal flexural strength, but that includes the value of A, which wasn't given, and it's not given in this diagram either. We have C, we have D, we have B, we have the area of steel, but we do not have that A value. So the first thing we need to do is solve for the A value, which is the depth of equivalent rectangular stress block. So that's going to equal the area of the steel, which is 24, and that's, I'm going to put parentheses around that, 24 times F of Y, which is 2000, divided by 0.85, and then we got times F prime of C, 1500, times B, and we know the width is going to be 1 foot or 12. We're going to need to convert it to inches since we have everything in inches in this case. So that equals 3.1373. I'm going to use 3.14. Now we can use that nominal equation there. So we've got 0.85 times F prime of C, which is 1500, times that A value, 3.14, times B, which again is 12. And then we're going to have times this value here, which is D, which is going to be, let's define D real quick, distance from extreme compression fiber to centroid of longitudinal tensional reinforcement. So it's the distance from the center to the area, or to the steel reinforcement in the block, and that's 0.75 feet or 9 inches, and that's going to be minus 3.14 divided by 2. And all that's going to equal 356,952.06. So you might think, okay, A is my answer, but we're not done yet. We need to find the design flexural strength, not the nominal, and the design is going to be greater. But how do we know which resistant factor to use based on this equation here? Well, it stated before it was a tension controlled section, so we're going to use 0.9. So we got 356,952 divided by 0.9. That equals 396613. So we're going to go with 400,000 here. So B would be the correct answer. So know your terms with this problem, calculate everything carefully, make sure your units are in line and in check, then make sure you design whether it wants to design flexural strength and nominal flexural strength, that you give them the correct values. The answer is B in this case. If you have any question about this problem, leave it in a comment down below. Anyways, we'll see you guys next time.